Good afternoon. Today we're introducing SolarUp, a revolutionary rapid shutdown module and optimizer by Enteligent. We'll be speaking with Sean Burke. He's the CEO and co-founder of Enteligent, a new company. So welcome to the webinar. You're going to feel incredibly pleased to have attended today because you're going to walk away with useful information on products that are going to make your work easier while delivering to your clients a much better value. We've also got a great story for you about Sean Burke, who founded Enteligent, about the company. It's a company that's developing all kinds of breakthrough technology for solar. You'll be excited by what's coming. So my name is Fernando, and I have the pleasure to introduce you to Sean Burke today. Sean, why don't we start with you telling us about Enteligent? Tell us about you and your team's background. You invented a lot of the things that we use every day, and it's a thrill to hear from the fellow that made them. So who are you? How did you get your team together? And what are you trying to accomplish?
All right. Thank you, Fernando. So let me give you a little bit about my background. I spent much of my early career in the computing industry. I worked for companies like HP, Dell, and did a number of products in the computing space: notebook computers, desktop servers, storage, mobile phones in different formats, even getting into smartphones and tablets. Me and my co-founders, we were working at a high-tech construction company more recently. And we were working on a lot of different products in the home building space and in the energy side of things. It's just a fascinating area. And I think we were really struck by the fact that solar energy, LED lighting, so many other new technologies are really DC oriented. Yet we live in an AC world. And whenever you go through conversions from DC to AC, you end up losing a lot in the processes. And it really got us thinking, and it spurred us to really look at where clean energy is going, and to develop higher efficiency products. We're all about wanting to get to kind of a clean energy world and get rid of fossil fuels. But if you look at clean energy today, it makes up a small percentage of the amount of electricity that's generated, and we all need to do more. And so this
3%.
is where we started thinking about efficiency and new products, and how do we do that and move that forward.
So now your first product, I think it's your first product that you're launching, is this rapid shutdown device. Why is that important? Why is it your first product, and why is it different than things that are currently in the market?
Yeah, good question. So as I mentioned earlier, when you look at the whole scheme of generating electricity and the use of electricity, one thing that struck us, and that was the industry really isn't focused on the efficiencies of all that. We talk a little bit about efficiencies in terms of solar panels and what their efficiency is, and inverters and what their efficiencies are. But the fact is, when you look at from beginning to end, the conversions of that going from solar panels that are DC to then convert them to AC, and you're going to the grid or going to a battery, and then you use them in your house. Most of the devices that we have in our house these days, whether it's an electric vehicle, I have a Tesla, or whether it's your mobile phone or computers, or many of the fans in your house, whether it's an HVAC system or fans in your bathroom or your kitchen, they're all DC. Yet we convert everything to AC to then convert it back to DC, and the losses can be pretty substantial. What we ended up doing is we want to increase those efficiencies, get rid of those conversion losses. We want to do it from the start. And so we're not going to really have an impact on solar panels. That's a big industry, commodity oriented product. The power from panels are going up, but we want to start from the beginning. And that is rapid shutdown devices and optimizers combined to then have the highest efficiency product right from the start. And then we're working and introducing new products as we move along to have the highest efficiency and be able to deliver as much electricity as we possibly can.
What's the advantage of the combination of the two? Like why would you combine it?
So in the US, in almost all of the US, if you have rooftop solar, you have to comply with what's called the rapid shutdown capability. And that is the ability to shut down the electricity generation from the panels in case of an emergency. And it's intended really for first responder type of situations, fire and so on, but it can evolve into others. But you have to, by code, have rapid shutdown capability on your solar panels. That is just a given. And so that was started to be implemented in the mid 2000s, 2017, and it's been revised again for 2020. It's going to get revised again, but that's required. However, there's also an aspect, a product that has been in the market of optimizers. So solar panels, and I think a lot of people on this webinar are used to this, solar panels are wired together on a string. If one of the panels gets shaded, it brings down the power generation of all the panels. And so optimizers are really intended to be able to have one panel that gets shaded, this power consumption goes down, but all the other panels continue operating at their fullest potential. What we ended up doing is developing an architecture where we are able to automatically switch between that full sun or RSD mode or optimizer mode automatically. And we're able to integrate that together. And we designed a product that does both of those things. Since you're going to have an RSD anyway, we were able to integrate in really the highest efficiency optimizer type of product into that device. And so all of your devices, all of your RSDs can have RSD and optimizer capability. And it's really for about the price of an RSD product alone. So that actually allows us to put it on all the panels, have optimization on all the panels, rapid shutdown on all the panels. And it also reduces some of the installation concerns of, do you put panels on some parts of your roof and not on other parts because they might get some shade? You put it on everything, they'll have the RSDs and optimizers. You're able to put more panels up on the roof, less concerns about some of the shade and so on. So we've combined it together into a product that is kind of cost effective, high efficiency. If it's an RSD mode, we're getting over 99.7% efficiency. If it goes into optimizer mode, then we are at a 98.7 or above percent efficiency. So highest efficiency in both of those modes.
Now, hold on, I'm interested. You said when it goes into optimizer mode, isn't it always in optimizer mode?
No, that's a good question. It does not. It determines. It has a microprocessor built into the product, and it will determine when the panel is producing less output because it's shaded. And so it will make the decision to go into optimizer mode. That's really important because there are some products on the market that are always in optimizer. They're always working, and they run at anywhere from 98 to 98.5% efficiency. So you're losing a certain amount of electricity from that, and the electricity is is in the aspect of heat loss, and so heat generation in those products. When they're always running in optimizer mode, they're actually generating more heat.
So they're putting an extra load on the panel, and yours is like a smart optimizer that shuts off, turns on when it's needed, and hence you don't have that bleed. Yeah.
If you have full sun, you don't need to be in optimizer mode, and so you get as much of the power coming from the panel as you possibly can, and you pass it through to the inverter.
Now, does that affect longevity too? I assume if your modules are running cooler because they're not on all the time, that maybe that would help a little bit in terms of longevity.
That really does. Is that there's some products on the market that are constantly running in optimizer mode. We see, at least from what we have been talked to with installers and new customers, that whenever they're running in that optimizer mode, they're generating more heat. And that is creating reliability issues. In fact, we have heard, we were in Boston at the Northeast Solar Expo, and a number of people came to us and just said, listen, I need to have another option. I'm getting a lot of failures from these different products. And that we believe is because they are generating a lot of heat because they are running in optimizer mode, and they are that heat causes, this is where we get this efficiency. The inverse of efficiency is loss, and loss it comes out as heat. And so you have heat buildup and you're generating a lot of heat in these devices. And that does create failures. It's stressing the components and it's creating failures and therefore the reliability issues.
Now, the optimizers generally have pretty good warranties. I assume yours are comparable to the market, but then there's the hassle. Even if you get a free replacement, you have to install it. You have the customer, you have all of that.
That's right.
And the hassle for the customer too, who may not realize that the optimizer is down, immediately, and hence has a loss.
You're right.
Yeah.
Yeah, that's right. I mean, it's yeah. So from the standpoint when we officially launch, and we'll be shipping production product in Q3 coming up, but our warranty will be as competitive as any others. But you're right. Not only is it about replacing the device, but you also have to provide additional labor credits for going up on the roof, changing those out and making it worth the installer's time. But again, the way we look at this is the best way of avoiding problems is having a good design, having as high as efficiency as possible, which means you're not really generating that heat and stressing those devices.
So I'm going to ask a few little questions here that I think are relevant in terms of the devices. I want to open it up to the to the attendees. If you would just go ahead and write your questions as they come up into the chat, and then afterwards, after a little bit here, when we're winding up the interview portion, we're going to look at what's in the chat and read out loud your questions, and Sean, I'm sure, can answer them. And that's a good time to get into the weeds if you've got some very specific technical stuff. But just in general, just some quick clarifications. Your RSD, I assume, is UL listed and it complies with the NEC National Electrical Code 2017 and 220?
Yeah, absolutely. Yes, in fact, yeah, our product will be UL listed, going through all of the testing that's required, and yes, is a part of the whole NEC code as well. One thing that I would also state is that we are also looking at having a SunSpec certification on this. It's a very important point. This industry has kind of evolved in a way where it's been piece part oriented, or it's been controlled by single suppliers that provide kind of a single solution, so kind of a walled garden approach. And we see it moving towards a more open industry standard oriented approach where different components can be mixed and matched. And what that's going to do for us as an industry is it is going to allow in more competitors, better competition, better pricing, new innovations and solutions. Similar to, again, as I said, I came from the computing industry, and there were initially in the computing industry,
plug and play.
Yeah, initially it was all these individual approaches, but what we got to is industry standards. So industry standards like USB that ended up, standardizing the way you can connect different kinds of devices and peripherals. That's going to happen with the solar industry, and this is the beginning. And we are very much behind SunSpec and moving that approach. So our products will be SunSpec listed as well.
Now, how fast is the voltage drop with your or the output drop with your shutdown? Like, how quickly does it work relative to the products? I think there's a 30-second or something that's got to drop within that period of time to.
So yeah.
Go ahead.
So there's two aspects, and again, this gets a little bit out of my range, but as part of the NEC code, in order to get rapid shutdown, it has it needs to shut down within 5 seconds.
Okay.
So very fast from the time that you actually press the button that you want the system to shut down. There's the other point that gets into, from full sun and getting to an optimizer mode or back and forth. Our optimizer actually responds very fast as well. So, it's within, it's a fraction of a second. So there's different aspects of this, but That's where our architecture in having a fairly powerful microprocessor in each device is able to do that. But by
Now,
code, you got to shut down within 5 seconds.
I thought it was longer, but good for the clarification. Thank you. Now, from the installer's perspective, what advantages? We talked about its lower cost because you've got one module rather than two, and you've got the one module you're going to have to stick on every panel anyway. What about you talked a little bit about the fact that you could maybe be a little more generous with your panels on the roof because you weren't so concerned with the shading and maybe a not so maybe not the best slope. What are some of the advantages? What doors does this open for the installer?
Yeah. So as you mentioned, and I kind of alluded to earlier, one is that we can put more panels on the roof, even if you're going to get shade in certain areas from a chimney, from a tree. By the nature of having an optimizer built into every RSD that you're going to have there anyway, you take care of that. So you're able to put panels where installers have typically avoided wanting to put some of the panels. In addition, we're using kind of what's becoming a standard MC4 connectors to be able to quickly connect all of the wires. We're using kind of an easy to install clips in order to be able to connect the RSD devices to the panels. So we've done actually a fair amount of mechanical engineering along with user testing in order to make it kind of simple and easy to install. And again, with microprocessor controlled system, it is really, in fact, plug and play. So we look at doing that and having it installed in simple and easy. The other thing that we're able to do is because our RSD optimizer is rated up to 900 watts, you can put panels for one
two
device.
panels. Is that what you said?
For one device.
All right.
And so therefore, you're only connecting one for every 2 panels versus having to put a rapid shutdown device on every single panel. So you can get it done in a little less time. So it takes a little bit of time away, and that makes it a little simple for the installer as well.
Well, I assume if you can put one RSD on every 2 panels, you're saving essentially half the RSDs.
That is kind of where we get to our cost, where it is the cost of just a straight RSD alone. And so that's a big component of it. Now, what I will say is that we have 2 versions. There's a single.
Okay, yeah. You have 2 of them.
Panels off of one. If one of the panels gets shaded, then they both go into they're both optimized. But we have a dual, and that can optimize 2 panels independently. So again, 900 watt rating. So you can have 2 panels up to 450 watts for either one. But we have the single and we have the dual.
Now, as the solar industry grows, and it's growing pretty dramatically, what are the issues you're seeing? Your first products are all about essentially increasing the efficiency of the system. Is that the heart of it, or where do you see the need for innovation?
Well, it's as we say, it's the beginning, and it's our beginning, and the SolarUp products are really looked at from our standpoint as really a beachhead product into the industry, but making efficiency a little bit more in the forefront and starting the narrative of that, because one is efficiency gives us more electricity, more energy from the panels. But as I said earlier, it also reduces the stress and strain on the system as well in terms of heat and loss. But that's the beginning. Where we're going with this is to introduce additional products that will, in effect, kind of complete our vision of, as I mentioned earlier, there's AC and DC, and I think it's been, we all know that there's alternating current and direct current, but when we start really thinking about it, every time we do conversions, we lose, as I mentioned earlier. How do we keep DC electricity that's generated from panels stored on the battery? It's stored in battery DC. It's taken to your electric vehicles or computer devices or fans in your house. How do we leave it DC? Now, there are certain companies that kind of have introduced concepts of microgrids, DC microgrids. We believe that's kind of going too far. I mean, we're not going to have houses that are totally DC. So we're going to have a time period where we have AC and DC living together and bridging to that future DC world, which we believe is going to happen. So everything from, your fans, your electric vehicles, batteries, LED lighting, that's all DC, but it's going to live within AC. And so what we're talking about is having a DC backbone switches that can move power from solar electricity to your battery, EV cars, as well as lighting systems and all the rest, while also utilizing AC for all the purposes that we're still used to it for. So there's a period where AC and DC have to live together, and that's where we're going to be introducing additional products. The next one next year is our EV charger, which is
EV charger. Okay.
which is powered directly from solar. So it has DC going straight from your solar panels to a car, putting it into your car, DC. So you avoid the car's internal AC to DC converter. So you can pump energy in faster and straight from your panels or battery. That's the product that we're going to be introducing next year, and it's both has AC power as well augmented by, DC power and augmented by AC. So you can get fast charges up to 25 kilowatts. So that's our product for next year. But again, it's bringing together this AC and DC worlds, but utilizing DC in its native form for the highest levels of efficiency.
So you're actually introducing a panel, the whole panel, not just you're going to have an EV station essentially that's going to go no conversion to AC. It's going to go DC straight from solar to the car battery essentially.
Through our EV charger, yes. So it's kind of a solar direct.
That's fantastic. And what are the areas that you see? I imagine, for example, refrigerators won't go all DC anytime soon because again, they got to sell appliances. Most people don't have a DC system. But you mentioned, for example, LED lighting. That seems like it'd be an easy one.
So
what do you see?
Yeah, interesting. So, and this gets back to we worked at Katerra, and I was president of Katerra Lighting, which was an LED business. I think a lot of people know, some people don't, but LEDs are DC. I mean, they're a DC type technology. In every bulb, if you go to Home Depot and you buy an LED bulb, inside that bulb is a little AC to DC converter in every bulb. And in fact, LEDs last a very long time, but I think we've all experienced that LED bulbs that we may have had have gone out and burned out. Yep. The chances are that it's that little AC to DC converter is what burned out. The LED did not burn out. And so what we learned there was there are DC lighting systems, but again, you don't want to be limited to just DC lights. You want to be able to have a selection. You want to be able to take advantage of what's out there. You can deliver DC to most LED lights today, even if they have that converter in it. It'll bypass it and it'll power that light. So you can provide, you can actually deliver DC electricity to that light and have it work, and also deliver AC electricity to it. And the more DC you provide to it, the longer you're running it on DC, it bypasses that internal converter. Again, it increases the life of things. But that's how we see things working. And to your point about refrigerators, well, many refrigerators and HVAC systems, they already have DC components in them, but there's going to be a transition period of being able to have power supplies that can recognize AC and DC together and be able to run those devices.
I can imagine like cords, you could have a different cord for your machine, whether you're going to run it AC or DC, something like that. If the converter is in the cord, like isn't a converter in the cord, or is it in the machine itself, like in a computer? You would know it's in the machine itself. Okay. Right. All right. Now, when will people be able to find your products on the market?
So we have, we will be doing our official launch and shipment in, it's gonna be August, September timeframe. We've already started talking with customers. In fact, we welcome, any installers or dealers who want to test out our product. We're picking select number to work with, based on region, based on the kind of installations they've got. But we're going to be shipping in volume and in production in the August-September timeframe.
And where will you be shipping to? Who's
We're shipping. We will be shipping directly to installers and dealers and
installers?
Yep.
Okay, so you've got people that are wanting your product. Like people could probably get a hold of you right through this webinar if they wanted to sign up and get product. Will it be retail that supply houses and such anytime soon?
These kind of products really aren't sold retail, at least not.
Right.
We see them primarily C&I type distributors and dealers selling to installers and electricians and others, and that's how we're going to be going to market.
So let's get into the nitty gritty a little bit. We have a few technical questions. One of them is a question I was about to introduce, and then I thought, well, maybe not. Maybe this is a little bit too nitty gritty. But can you tell us a little bit more? This is from Lindsay. Can you tell us a little bit more about how the SolarUp Optimizer switches in and out of optimizer mode? Like how is that triggered?
Yeah. So as I mentioned, SolarUp has a microprocessor in it. It's able to see what the line level is coming in from the other panels, and it's also able to see what the amount of output from that panel that it's connected to. And that microprocessor makes the determination if there's a variance between the two. It is able to switch it into that optimizer mode. Now, if all of your panels, let's say it's kind of a hazy day and such, or the sun is in a different level, all of your panels are kind of having the same level. So it doesn't have to go into optimizer mode. It's whenever there is a variance. But that microprocessor, based on the differences in what the other panels are delivering and what that panel is delivering, it makes the determination. And so it's kind of an intelligent and automatic switching over to, between the modes.
In terms of maintaining the system, then what about monitoring? Is there any kind of a health check, if you will, of the panels?
Yeah, good question. So that's another unique thing that we have, is that our product does a self-diagnostic whenever it starts getting when it gets powered up. So start of the day, it will run through a self-diagnostic to ensure that all of the components are working and that it's going to be able to deliver power, but also, and again, its primary requirement as an RSD, that the rapid shutdown capability is intact, and so that's very important. So it does that diagnostic. We have not seen anybody else with that capability, and in fact, we have filed, for our intellectual property on that type of feature. So yes, it does that. One thing.
How does it communicate? How does it communicate? And me as a homeowner, I guess I'd be the first one that would need to find out.
So we basically are using PLC technology. So
what is PLC? Power line.
So the wiring that is delivering the power is also delivering the data.
Okay.
I did see one question that came up of do we do panel level monitoring? The initial products as they go out do not have power level monitoring. However, we have an update that's coming later in the year that we will be able to deliver data, panel level data through PLC to the inverter. And again, we're actually working with other inverter companies right now in order to be able to provide that data to the inverter itself, and to be able to give you panel level information. One thing that, again, coming from kind of the computing world and mobile world, one thing we don't want to happen is for every single device to have its own app. We would like to be able to integrate that and work with other partners of having kind of a portal for all of the information. And so you can get all your information of the inverter, of the panel level details individually. Now, one thing that just occurred to me, whenever some people talk about, do you provide panel level details? There's a couple different aspects to that, and there's really three that we have come up with. One is it for installation purposes? Once you've installed it, you're able to check, that installer is able to check and see that everything is working properly. Okay, and we'll have the ability to provide that. The second is, does the homeowner have the ability to see it? And so we see less interest in that, at least from what we've talked to. There's some people obviously that are a little more tech savvy and interested, that they want to be able to see how their panels are working. That will come later. And the third is from a serviceability, kind of a maintenance and just checking things on an ongoing basis to make sure that your system is operating effectively. And again, we will be putting together some capabilities of being able to do that for our installers and service personnel.
Now, what about compatibility? Are there any issues? Can I change existing RSD devices with the SolarUp RSD? Can I get still optimization? Can I retrofit? Or what about with different kind of the more popular or the prevalent systems out there?
Yeah. So again, as I said earlier, we're very much behind SunSpec. So other SunSpec oriented inverters, we will operate with them. What we see is from people who have systems that want to retrofit, we see that as, and we've actually gotten interest in that. I think there's probably less interest for people wanting to put RSDs on their roof if they have a legacy system that they do not have RSDs. Although I'm sure there are people who may want to have that or may want to add optimizers, and they could certainly add ours to those systems. But we see the biggest opportunity are new installations going in that just require RSDs, and it provides the opportunity of having optimizers with their RSDs that are going in. So small opportunities on the retrofit. We see the bigger ones on new installations. However, I think that the retrofit side, we get those questions, but another thing that we are also seeing more and more of are people who have had systems that were installed 8 years ago, 10 years ago, that the panels are kind of lower output panels than what's available today. Right. Also, people have evolved since 8, 10 years ago. Maybe they got an EV car, and once you get an EV, your electricity consumption goes up significantly. And so I'll often ask people, say, well, you got, in fact, there was a neighbor that met with, and he was asking what he should do. I said, okay, you got it 8 years ago. Did it cover your electric bill? He said, yeah, electric bill was covered. What about now? It's not now. He's using a lot more electricity. And so increasing the solar on his house would actually provide real returns to him. And so there's those mixtures of people. So it's not simply just putting an RSD on a small panel. It may be that homeowner may want to upgrade and update the panels and the entire system because their demand, their usage has gone up and changed.
Now, when Shyam, I'm not sure the whole name doesn't come out for the last name, so I apologize to you, Shyam, but he's asking, I'm not clear on the question, but how does 25 kilowatts in the EV charger compare to what is currently available?
Oh, good. Yeah, good question. In many cases, people have, and it varies. So if you put if you go to a charge point, kind of commercial charger, and you go to a charge point, you're going to get about a 6.6 kilowatt charge. That's about 18 to 20 miles of charge per hour of charge. If you have a circuit in your house and you put a 40 amp circuit in, you're probably going to get somewhere around a 30 miles per hour charge, and somewhere in the 9 kilowatt range. 25 kilowatts, significantly higher than what you're seeing today. And part of it is, so when we say it's like 3x, 3.5x more than a kind of a level 2 AC charge. Part of it is the circuit that you're having, so the amount of electricity you're delivering. Another part is the car itself and what it's able to take in. Teslas have a higher input capability than other cars, say a Volt or a Leaf and so on. So that makes a big difference. So, but the infrastructure you have in place, the car itself, and those are going to determine. But again, anywhere from 6 to 8 kilowatts is about what the norm is for AC level charging. and let me just reiterate one thing. There's a big difference, and I think many people don't realize this. There's a difference in that AC charging versus DC. For AC level charging, if you get an EV and you put a circuit in your wall and you plug it in, it's going AC from the wall, obviously, into your car. And your car has an AC to DC converter. And that converter, there's different limits to it based on the car, but it has to convert. Now, when it does that conversion, you will lose up to 10% of the electricity through that conversion, that AC to DC conversion, because it's storing it onto a battery. When we go DC, we are actually delivering DC straight to the car. So we're not having to go through that converter. I think I mentioned it earlier, but it means you have very little loss in terms of that conversion. You're just doing a DC to DC conversion into the car and onto the battery versus where you're limited to with what's called level 2 AC charging.
Yeah, Brian Reeves clarifies or suggests residential AC level 2 chargers typically are 9 kilowatt at 40 amps, a little higher than what you were saying.
Well, and keep in mind that 9.6 kilowatts, you're going to have the 10% loss from that conversion that's going through the converter. So you're down around 8.5 kilowatts of actually delivering into the car.
And I assume that the cars have the ability to detect whether they're getting AC or DC and just allow the DC in.
That is correct. That is correct. And there's different cars have different capabilities. There are some cars that are electric vehicles plug-ins that do not accept DC charging today. The newer ones, Teslas. I have a Tesla. If you go to a Tesla supercharger, you're getting that high rate of charge via DC. Other cars that are coming out are DC. In fact, there's standards that are getting created. We're going to end up moving to a DC world, and all electric vehicles are going to be accepting DC charging. But there are a few that right now don't.
Now, we've been focused here on residential applications. Is your rapid shutdown product suitable for commercial applications like 480 volts?
So there's a difference between the inverter electricity and the panels themselves. But I would have to let one of our engineers kind of talk about for the commercial applications. What I would say is that there is we like to talk about residential and commercial, but a lot of commercial buildings, small commercial, it's utilizing similar technology and similar products as residential. And so we do blend over in that space for our SolarUp products. For the EV charger, it does span between the two because it's where people are going to charge, it's where solar is installed, and it's about charging your car where it is during the day when the sun is shining. And so we have gotten a lot of interest from commercial applications, whether it's office buildings, stores, retail centers, different fleets, and even the canopy suppliers that have canopies, shade coverings that have solar on top of them. So there's a lot of application for the EV charger in those scenarios.
Yeah, and the thing holding back the electric vehicles is, of course, the charge speed.
That's exactly right. And as we move forward and have more EVs, you're going to have places to charge them. And so that is, we think that there is a robust market for it. What I would also say is, with that, there's really a blending of different worlds that are coming together as we talk about the EV charger. I know we were talking about this a lot, but the current EV charger market is really oriented on the automotive side. You buy a Tesla or you buy a Nissan Leaf, you're going to have to get a charger installed, and you're talking to the dealer about how do I get installed, who do they recommend to install it, and so on, and you go to electricians. However, as we start looking at EV chargers like ours that are powered off solar, it provides the opportunity of solar installers to get into and start selling much more into this space. And so it's really now looking at it from, it's a solar driven product and accessory not really a car or automotive driven accessory so much. And so, and this is where a number of the installers that we have been talking to about this, they see an opportunity of an additional sale. You're getting solar, do you currently have, or do you expect to have an electric vehicle in the future? Yeah, if the answer is yes, then this is the kind of product for you. Put it into the entire installation, and then you're covered. You can do the financing all together. It's all done at one time, and make it simple, easy, and you're covered for the future.
Now, this is a question on my ignorance. If you're going DC to DC, direct solar panel to the charging station for your electric vehicle, do you still need to involve the electrician, or is this something now the solar subcontractor or the solar contractor can do entirely?
So it's kind of a yes, but DC electricity, it's up to a limit of what you're able to do without being an electrician. However, solars have the ability to, whether they're licensed electricians, depending on the area or not, they can install this. However, our EV charger does also connect to AC, because you want to let that charger to work. If you have no solar, if there's no sun and you have no battery, it's also augmented with AC electricity, and you would have an electrician put that in. So you still need that, we believe, and that's an important, to be able to have the supply of electricity, both DC and AC.
Now, Dean Mail wants to know, he says there's been a lot of quality issues in the optimizer marketplace, and how does your product differentiate itself from the others? Quality, I assume they're meaning durability.
Yeah. So I talked a little bit about this earlier, but so our product. So let me kind of take a step back and kind of talk about a little bit about our background and our engineering group. As I said, many of us, all of us at Enteligent, had worked in the computing world. So actually doing more integration, utilizing kind of latest components and technology, but really in the effort to reduce the size of products, whether it's a notebook product, whether it's a mobile phone, but getting things smaller, more efficient, again, less heat, because we take up performance. That was a big part of it. And so high efficiency is very important. And also cost. In the markets that we've been in, cost is very important. So our engineering group has been able to really architect this in a way that we have 30% fewer components than some of these other optimizers that are on the market, and they're higher efficiency. And again, the efficiency is important. It really hasn't been looked at this way, because it's like, oh, okay, I lose a couple watts here or there, but it's not. That's not the point. If for example, there's an optimizer that is in the market today that we're hearing a lot of complaints and hearing a lot about the failures. I won't say the name, but they're at.
But the smile gives it away.
They're at 98 to 98.5% efficient, and they're always in that mode. They're always in that optimizer mode. So what does that mean? So let's say the 2%. So what's 2%? Seems like a small number. Well, if you have a 300 watt panel, that's 6 watts, and that's 6 watts of heat. That loss is heat, and so you're always in that mode. You're always generating 6 watts of heat in that little box, and you have to dissipate. And so that stresses things. As panels are getting more higher capacity, so 350, 400 watt panels now. That's 8 watts of heat that device has to dissipate. Ours is less than one watt. So 30% fewer components. The efficiency means less heat. So less heat to stress the components in that device, and that which eventually heat and the expansion and contraction really means failures. And so that's where we believe the reliability issues happen. So people should look at efficiency, because the inverse of efficiency is loss and heat and failure. And so that's how we're looking at it. But it's our background of trying to get to more efficient designs, utilizing new process and technology, and componentry, and doing it with as little loss as possible really improves the reliability of it.
Now, Dean asks, and I think you answered this, but does the optimization provide maximum PowerPoint tracking?
Absolutely, yeah, absolutely, absolutely. That is a big part of what of what we've looked at, and so MPPT is absolutely paramount. So yes, it does.
Okay. April just comments, which I guess a comment you'll probably agree with. So the RSD optimizer feature of the SolarUp actually makes it easier to design a solar array because you don't have to make the choices of where to optimization. You know, I'm being a little bit facetious with this comment, but actually it's a very important one because it in a sense, is an art to installing the panels, which is guesswork in part because, for example, that little tree that's in the new subdivision is going to become a huge tree in time.
Right.
You know, in that time, maybe 5 years later, all kinds of things happen to, like clouds,
Yes, yes.
birds. You know, so it does take. I think it does give you a much more surefire way of designing a system without having to worry about those things that you may not even be able to control or even anticipate.
And that's right. We're learning things all the time. There was a friend of mine who was telling about his solar installation, and he got quotes from different companies. And when they talked to him about where the panels would go, he's like, "Well, why aren't you putting panels over here and over here?"
Mhm.
And they just said, "Well, we're the trees at this part of the day are going to hit these panels, so we just kind of condensed it." And so he could have, if the solar installers that he was using looked at having optimizers, they may have considered putting them in some of the fringe areas, but they didn't. So they ended up kind of quoting a smaller system that was probably possible to put on his roof. So it
Mhm.
meant less money to the installer and it less capacity for him. But the installers were also very concerned with not kind of putting additional panels in areas that would increase their quote, and also kind of have them stick out relative to some of their competitors. So you're right. It kind of gets to this point of where installers have avoided certain areas because
Mhm.
of shadowing, or they didn't want to really propose having optimizers in just some panels and not others, and increase the quote. They just eliminate putting panels in those areas. So
Mhm.
this does provide an opportunity of load it up, put them on, and if that tree grows and starts getting shaded, shading a panel, you're going to be covered. If the chimney at the end of the day is going to cast a shadow, you're going to be covered. So
Mhm.
this is the part about, we just think it makes it simpler, it makes it easier, and you're going to ultimately get the maximum amount of capacity from your installation.
Now, the benefits as we're talking are obvious, but you didn't come from the solar background. You're not a solar installer, right? How did you get, I mean, what was the catalyst for thinking of combining these two things?
Um, so I come from a product development background. So again, a number of products. In our last company that we were at, we started thinking about this a lot more, of the efficiencies associated with it, and there was even again, we don't come from a solar background, but we did a system
Mhm.
that relied on solar energy. It was a large energy system that took solar electricity in, also combined it with battery and the grid. It had AI components to it to be able to
Mhm.
determine when to utilize grid level electricity, when to store to battery and use from battery or solar or grid,
Mhm.
and did it all intelligently. And it got to the point of us, looking at a cost breakout, and somebody had pointed out, you don't have RSDs on here, and it changed the cost aspects of that system. And so we started really talking, well, what are RSDs, and when do you have to have optimizers, and we saw this um, different products in different areas, and we started looking at it and going, it doesn't really make sense. You can integrate both of them together, and again, looking at our engineering group,
Mhm.
our head engineering of power is a gentleman by the name of Bahman Sharifapur. Worked on many different products in many different industries. In fact, if you have an iPhone, that little white iPhone adapter, he
Mhm.
invented that. He came up that when he worked at Flex. but many other things. He's able to look at it with that product development eye and say, it doesn't make sense that these things are separate. And for the ones that are on the market that do both RSD and optimization, they were really architected and designed in a way that wasn't efficient, was complicated. Some of them, there's actually one supplier that has this wireless network to be able to get that. And that just complicates things from what we've seen and from the testing that we've done.
Like a Wi-Fi network when you're saying
Yes.
wireless for community. Okay, I see. Yeah. Okay.
Yeah, and it just did make sense. It complicates things. It makes it a more complex installation, more time, and so they did solving. And so it was putting the combination of things together, because that's where we saw the market really what it needed in order to make it a simple, easy plug and play installation. And again, avoid the aspects of, do I put optimizers on these panels here, or avoid putting panels on the roof because of this, and just combine them together. It's possible to do that.
Now, do you have installers already signed up or installing your product? Do you have any installed, or can anyone get a list of can I think Rodrigo is asking this question, and I think he may be one of the consumers. I remember there was one on the list that said he was just curious, interested, et cetera. That maybe that's Rodrigo, but he's asking, can I call? Do you have a list of people? Might there be somebody in my area?
So we're very early on. We do have a handful of installers that are doing installations with our product. It's kind of early installations, but real world. And so we do have those. We're looking at others. We have some opportunity of being able to expand the installers that we work with on early installations, but we have some that we can refer to. And let me just also say one other thing with regard to the installation and reliability and testing. And you did ask the question, but all of our products, we're going through all of the, not only the UL testing that you had brought up earlier, but also kind of highly accelerated life testing and different environmental testings and so on at a very detailed level. Installations that are going in really right now, the end of this month, beginning of July, those will be the first ones, and we'll be getting a lot of data from that, I'm sure. But the rest are we're looking to expand some of that.
So if Rodrigo wants to find out if you might have someone in his area, or if there's someone you might work with, how would he get a hold of you, or who would he talk to? How would he?
He could go to our website and send us a message, or even at sales@enteligent.com, and we'll be happy to work with him. And I don't know if Rodrigo's just a homeowner and looking to get something, or if he's an installer or a dealer. We would love to be able to speak with you and see what kind of.
He's an interesting category, very interesting category. In fact, a growing category. He's a general contractor. He's a builder that works with clients that want to consider solar systems, but don't want to deal with all the hassle. So he's going to get involved in setting these up. So he's here doing his homework, basically learning about it, so that he can serve his clients.
So we are, and that's home builders, tremendous. In fact, you're kind of an esteemed writer for a number of home building publications, but getting in with home builders, extremely important. Being able to design it in as you're building the home, you have a lot more flexibility and ability to put in some of these different systems. Very important. We're working with actually one of our early partners is a home builder in Texas that we're putting in a number of our products and doing work with them. So we're helping with the design. We're being able to provide some information on how to architect it and so on. But we love dealing with home builders, and we even can look into the future of being able to utilize again that AC DC capability interchangeably for the other wiring in the house, like LED lighting systems and so on. Whole different topic, but yeah, we would welcome that.
I just went ahead and put the Enteligent website on the chat so that Rodrigo or anybody that's interested in getting in touch with you, I assume you have a contact button on the website that they can contact. So and also someone just put in sales@enteligent.com. .com, easy website there, easy email address. So there's that. We've only got a couple of minutes left, and I I wonder with now you did name names when we spoke. We had kind of a pre interview chat, and when we had the pre interview chat, you named names of some of the inventions that you and your team had been involved with that were, that really, set your credibility for me. Like when I realized like I'm using one of those right now, it kind of like, wow, that's the guy that made it. So maybe you can't really talk about that publicly, but if you can, to what extent you can, love to hear about it. Because with your history of innovations, which I have the privilege of having some brands and specific devices, knowing about them because you've told me. So with your history of innovations, what made you decide to concentrate on solar?
It is a combination. Again, as I said, our last company where we were getting involved in this, but I think it's a little bit more than that. When we look at the changes in our world from an environmental standpoint, we absolutely need to do a better job environmentally. So, looking at the emissions that we're creating, all the fossil fuel burning, and we're so far behind in terms of the amount of clean energy. I mean, if you look at really clean energy, and we did an article about this of, clean energy, sustainable energy, and renewable, and they're all very different. Sustainable is not necessarily clean energy, and so when we talk about that, we look at clean energy. There's solar, there's wind, and there's hydroelectric. I mean, those are really the clean energies, and if you add them all up, I think you get to somewhere around, it provides 6% of the, or maybe 7% of our total electricity supply. The rest is fossil fuels and things. And so there's that one aspect. We got to do a much better job. And so how do we do a better job? Well, we make the supply side of it better in terms of, generating more electricity, losing less, making it more affordable. So, whenever somebody looks at putting in solar, they always do the financial calculation. Does it make sense for me or not? And then, if it does, then they do it. But we want to make it more affordable so that it actually accelerates the adoption of rooftop solar and accelerates the adoption of solar in general. So that was one thing. Is kind of more of what we want to do to help the environment and such. But the other aspect, Fernando, it's like, as we talked earlier with EV cars and the desire to move on, get away from like natural gas connections in houses and things, electricity demand is going to go up significantly. And unless we, and again, we're trying to make clean energy a bigger mix of the supply, but you have doubling of forecast for doubling of electricity demand, in the next 20 years. We have to do a much better job. And so we looked at that one as an opportunity of getting on, the bandwagon of delivering better products, helping to improve the adoption of solar, making it more affordable, and really, helping the environment and helping this whole effort to get to, a better world. Even getting past all these different aspects of it. Is it a net zero energy by 2050, or is it, an SDS policy or standards? We just got to do a much better job. And even if we just kind of increase it, a bit, it's going to mean a 25 to 30% growth rate for solar over the next 20 years, each and every year.
40 I looked it up today. 42% growth rate year over year since the year 2000. Now we've got about 30 seconds left, and poor Shyam has asked this question now several times, and I thought we answered it in a generic sense because you referred to the standard. But what are the typical inverters that this RSD Optimizer will work with? In other words, he's probably an installer. He wants to know what's compatible with it. Can you name some names, brands?
Yeah. So if you go any of the SunSpec type inverters, so I'll name some names. Companies like SMA, Fronius, Canadian Solar, Yaskawa. Those are the the inverters that are behind SunSpec and that we connect into. They're the big names. You know, you go from the big players in the industry are Enphase, which is a microinverter, which we think there are negatives to that, particularly as we move forward. Higher capacity panels, battery, and so on. Doesn't really work as well, lower efficiencies. And the other one is SolarEdge, string inverters, but it's kind of a walled garden and kind of a proprietary kind of solution unto itself. It's a lot of the other guys. It's really almost all the other guys.
All right. Well, we're out of time, Sean, but it's been a fantastic discussion. I really appreciate it. I feel learned a lot, and you're doing well by doing good, I guess would be the way to describe
Thank you.
the opportunity. So thank you so much. Really appreciate your time. And again, you've got Sean's email address. You've got the website. So the questions you didn't get answered or you need more clarification for, just reach out to Sean, and him and his crew, his technicians will certainly get back to you. Thank you so much.
All right. Thank you, Fernando. Thank you, everybody.
Bye-bye.